Hi, this is Greg Monty. I'm the director for the Energy Research Center at A&T, and this is the Generate game portion of the energy generation module. And what we're going to do today is actually play some of the game called Generate, which was developed by the Environmental Protection Agency, the EPA. And it's a game about understanding energy system choices and challenges. So let's keep going. This is just a quick review. You covered some of this in your last class and in the last video that you watched of me talking about energy generators. I just want to repeat that there are some significant pollution coming from energy generation with nitrogen oxides, sulfur dioxides, carbon monoxide, and mercury getting put into the air. In addition, greenhouse gases are very large from the CO2 emissions, and it's believed that it contributes 94% of the U.S. carbon dioxide emissions just from energy sources. And the last thing that's used up a lot is water. We don't really know this too much, but all of these different turbines that are being run in carbon, in coal, natural gas, and nuclear power plants take a lot of water to cool the turbines from their spinning and the friction. It actually consumes about 41% of the U.S. water withdrawals from streams, rivers, lakes. Comparing that just to the agriculture, you see that it's actually more than the agriculture, which comes in at 37%, and the public supply that we use for drinking and other things, cleaning our clothes, is only down in the 13% range. About 200 billion gallons of water each day are required to cool the power plants in the United States. So water issues are a serious problem. This is another good reason for replacing coal, natural gas, and nuclear with things like wind and solar that don't use water. So let's continue. The Generate game is what we're going to play today. We're going to go through 4 rounds, and you're going to have a team scorecard that looks something like this in your hands. And we're basically going to simulate an energy system like a community or a city. And we're going to look at challenges and trade-offs as we put energy onto that grid. And each of the teams is going to have the same total energy of pieces in their kits that they use. You all have a different mix of those energy pieces. And our goal in every round is simply to achieve the lowest possible score or the lowest possible cost of implementing your grid for the people that need energy. The scores are calculated by looking at the purchase cost for a particular type of energy generator, the operating cost of that energy over a 30-year period, plus carbon dioxide costs. In some cases, the type of generator will produce carbon dioxide like natural gas or coal. Other cases, like wind and solar, there's no carbon dioxide emitted. So the cost of carbon dioxide is 0. So you're going to get a game board given to you by the teacher, and you're going to have to fill up this board. You want to fill up the pieces such that you can read them in the normal horizontal fashion. When you put them on the board, don't turn them 90 degrees because that's not allowed. And you're going to use this board for multiple rounds of play, rounds 1, 2, 3, and 4. And each team is going to try to, you're going to fill this board, and you're also going to try to reduce the total cost of putting your grid in place. So get your notebooks out and your grids and your playing pieces out of your pouches and lay them out on your table. These are the types of pieces that you should be seeing in front of you. You may not have all of these pieces. Some people don't have nuclear, for instance, but a nuclear piece is the largest one, as you see up here. We have coal. That's new coal plants. This is existing coal plants, and this is what we would call coal CCS, or that stands for carbon capture and sequestration. So it's the capture of carbon dioxide. I might point out that there is no such operating coal power plant in the United States today. they've been trying to build carbon capture and sequestration plants for coal, but they haven't been able to figure out how to make it work yet. Natural gas is shown next, and then renewables are shown in the upper right. You have wind, large wind, and wind using battery backup. Same thing for solar. You have small solar, large solar, and solar with battery backup. And then lastly, we have two pieces called energy efficiency. These pieces won't be played until the last round of the game. So in rounds 1, 2, and 3, you will not be using energy efficiency pieces. What do the numbers and lettering on these playing pieces mean? First, on the upper left corner, we'll describe the type of energy generator you're working with. The next upper right corner is how much does it cost to build or purchase a plant. So it's very expensive to build or purchase a nuclear power plant. The bottom right corner is how much does each cost to run or operate each year. So that has to be multiplied by 30 to figure out the total operating cost over a 30-year period. And this is how much, on the lower left side, how much carbon dioxide is produced from that particular energy generator. For nuclear, it does not produce carbon dioxide, so the number is 0. So the way total cost is actually calculated on a spreadsheet that you have available to you is that you take the cost to build or purchase a plant plus 30 years times the operating cost plus 30 years of the carbon dioxide cost, which would be 30 years times the amount of emission times the tax on carbon emissions, carbon dioxide emissions. In this case, that turns out to be 0 because there's no emissions from nuclear. So the total cost over a 30-year period, relative cost is $28.75. And this is calculated for you automatically on these spreadsheets that you have in front of you. You have something called the Generate Calculation Support Sheet to help you play each round of the game. And they'll be labeled with the carbon tax value on the upper left-hand side of the spreadsheet. And there are two of these. There's one for $0 and one for $10 carbon tax. And what happens is this is sorted in increasing cost value. So as you build and fill in your grid, you want to build it with the lowest cost pieces first. So you'll be using the ones that cost the least amount. In this case, $19 for existing coal. And then natural gas is the second cheapest, and so forth, until you fill up your grid with the types of pieces that you have. Again, we're not going to use these energy efficiency pieces until the very last round, or round 4. One thing I want to point out here is that this is truly representing the way things cost in the world today. Existing coal is relatively cheap because no one is using carbon taxes today. So with a very low carbon tax, coal seems to be an inexpensive way to generate electricity. And natural gas, as we all have been hearing, is also relatively low. But then wind comes into play, small, large, and large wind with battery, followed by solar. And then you come to the building of new coal power plants, or the running of nuclear plants, or lastly, carbon capture and sequestration plants, which are very expensive because it's just not easy to capture the carbon dioxide emissions from those plants. So that's a realistic representation. If you look at the $10 carbon tax, that changes dramatically. So if you put a carbon tax on which is taking into account the health and emissions into water and air, and then storm recovery costs that we all feel across this nation, then you see a different result. You see all of the renewables popping up to the top and being the cheapest. Wind, followed by solar, and then by nuclear, become the cheapest because they don't have any carbon emissions. And those kinds of energy generators like natural gas, existing coal, carbon capture and sequestration, and then new coal are the worst performing energy sources. And they would be last in any implementation if you had a carbon tax applied to the energy generators. And I think we talked about in the last class that energy efficiency is the cheapest of all forms of energy generation, because If you just save kilowatt hours by not using it and not burning energy, then you don't have to build new power plants, and you avoid additional costs and you avoid carbon emissions. So what you're going to have in front of you is a team scorecard. If you can download this scorecard from a website, either your teachers or from the website at North Carolina A&T, then you'll get an Excel spreadsheet and you'll be able to count your pieces, put those numbers into these columns for round 1, round 2, round 3, and round 4. And if you do that correctly, if you filled your board correctly and you've counted your pieces correctly, the number on the bottom should come up to 352 for each of your rounds that you're playing. So please make sure that that's the case, and then bring those numbers up to your teacher, and your teacher will put your scores or your numbers of pieces into the scoreboard for all the teams that are playing this game in your class, and you'll have a chance to do some comparison. And that's what we're going to do in each of the 4 rounds. So keep this scorecard available to yourself, either on your computer screen or in a hard copy. If you have a hard copy, the only way to check whether you got 352 is to take the numbers up to your teacher, and they'll submit those to the scoreboard, and the scoreboard will do a check to make sure that you've covered all 352 rectangles on your grid. So let's play Generate. The idea here is to fill up your grids with the pieces, no overlap between pieces. All of the grid needs to be filled out to the outer edges of the grid. And you're going to use that calculation support sheet to guide your strategy for which pieces to use. Remember, we're trying to produce energy at the lowest possible cost, which is the rule basically that all energy companies must follow, such as Duke Energy. They're trying to produce energy for the least cost to their users. And then you're going to count up the number of pieces of each type that you used in each of the rounds and put them on your scorecard to check to see that you got 352, or bring them up to your teacher to have that checked in the scoreboard. And then you'll have a chance to compare and contrast your scores or your cost of your grid implementation to those on the other teams in your class. And remember, energy efficiency pieces will only be used in round 4. So let's do round 1. The goal again, lowest cost. You want to use the lowest cost from that calculation support sheet. And there's no carbon tax in this round, so it's $0 per megaton of carbon dioxide emissions. So please play your pieces and then count the number of pieces you have, put them on your scorecard, and bring them up to your teacher for a comparison between different team members. And this sound, laser sound, and the sun on the page is an instruction for the teacher to pause the video while you're playing your pieces, and then come back and restart the video when you're ready to have a discussion. So now round 1, observations. It's probably the case that the team that had a lot of existing coal ended up having the cheapest implementation of their grid. And that's because we saw that existing coal was the lowest cost energy generator when you have 0 carbon tax. So take some time to look that over and see how your scores compare, and maybe compare some of the teams' different types of pieces that they had to play based on the pieces that were given to them. Now in round 2, we're not going to actually change the board in any way, but your teacher is going to add a $10 per megaton of carbon emissions tax to the scoreboard. So by filling in number 10 in the yellow square on the scoreboard, all of the scores are going to change. And your job here is just to notice, how did the scorecard change? How did your score change from round 1 to round 2, and why? So now that your teacher's made that change and you've had a chance to look at the scores up there, you probably saw that the teams that did really well in round 1 probably did not do as well in this round. And that's because coal, which has the highest carbon emissions of all the generators, is being taxed to represent its true cost to society and to people who are using energy in this country. So the carbon tax is penalizing coal, natural gas, and other forms of carbon emitters because they produce carbon which causes health problems and environmental problems that we have to pay for to remediate. Okay, so now let's move on to round 3. In round 3, what we're going to do is we're going to allow you to now redo your grid with that $10 carbon tax and come up with a minimum implementation. Remember, in round 2, all you did was you used your original implementation with $0 carbon tax and just added a tax to it, and you saw the implications to the cost of your grid. This time you get a chance to actually minimize the cost of your grid using a $10 carbon tax. So please use the spreadsheet on the calculation support sheet that guides you as to which pieces to play first with a $10 carbon tax. And then count your pieces and bring them up to your teacher to put into the scorecard after you've validated that you have 352 small rectangles covered. So what do we observe in round 3? Well, it turns out that that $10 carbon tax really gives a lot of advantage to wind, solar, and nuclear. And if you had a set of game pieces that had a lot of wind, solar, and nuclear, you probably scored the lowest in terms of cost compared to the other teams. And that's because the emissions are 0 and the carbon tax did not impact the cost of those types of energy generators. The people who had carbon emissions energy generators such as coal, existing coal, new coal, and carbon sequestration coal, as well as natural gas, probably saw their scores go up dramatically. All right, so now the last round of generate is what we're going to do now. Here we're trying to do it for the lowest possible cost, and the idea again is to use 0 carbon tax in this round, but use all of your energy efficiency pieces as well. So clean your boards and go back to the $0 carbon tax on your calculation support sheets and use that along with your energy efficiency and see what kinds of scores you get for this round. And I think you're going to notice that the scores go down because, as we said, energy efficiency is the cheapest way of implementing energy sources and keeping the cost of electricity low. All right, so what you see in this last round is that the existing coal with lots of energy efficiency probably came back and did relatively well because, as we said, when there was 0 carbon tax, existing coal was the cheapest form of energy to implement. And then if you add energy efficiency by saying we're just not going to burn as much electricity in our homes, in our buildings, then we don't have to produce as much energy. And existing coal then becomes a favorable way of dealing with energy generation. So, as we said, energy efficiency is the lowest cost approach for energy generation. If we use less energy, we build fewer power plants, and we need fewer power plants, and we reduce the cost and the carbon emissions at the same time. So that's the end of the Generate game. I appreciate you playing along, and I hope you learned something about the trade-offs that take place between energy generation, carbon emissions, and cost. Thanks very much.